Okay, we are on 2.6. We're going to do this for 2 days. So we're temporarily going to say goodbye to polynomials, and we're now going to say hi to rational functions. Rational functions. What is a rational function? What's the key word in the word rational? Ratio, very good. Ratio means what? Fractions. So we're going to look at rational numbers, which are fractions. The most basic rational function is y equals 1 over x. Y equals 1 over x. So you have to remember how that looks like. It's this one with the first and third quadrant. This is the most basic rational function. So let's just look at the first one. We're going to determine the transformation from 1 over x. So this is 1 over x minus 2. So what is the transformation? 2 something. Left, right, up, down, stretch, compress. Right. There's nothing else. It's just right 2. So then what we want to do is kind of start from our parent function, which has 2 asymptotes. One is the y equals 0 asymptote, and one is the x equals 0 asymptote. What we're going to do is move this graph 2 to the right. We're moving it 2 to the right. That means the asymptote is going to move. And the horizontal asymptote stays the same. And then we just kind of graph like that. It doesn't have to be perfect. We just want to sketch. Okay, so let's, you guys doing okay? Yeah. Okay, let's skip the second one for now. Let's look at this one. So go ahead and write down the transformation and sketch a graph. All right, before you continue down the wrong road, we have to try to find the 1 over x in this function, right? You can kind of see that plus 3 is going to kind of make it go left and right, whichever one you decide that was. The 2 does what to the function? Stretch. Okay, so 2 is really like a 2 multiplied to this whole thing. So that is outside of the function. 2 is the stretch. Okay, so this is actually going to be left 3 and then vertical stretch 2. Okay, go ahead and finish graphing this. Okay, so if you're wondering how to stretch 2, there's nothing you can do right now unless you plug in points. So I'm just going to make it a little bit longer than normal, maybe. That's it. I mean, we're not trying to be very accurate here. Now let's go back to the second one that we skipped. First of all, is this a rational function? Rational function means x is in the denominator. So is this a rational function? Yes. But does it look like 1 over x? No, not at all, right? Because in the numerator, there's another x. So this does not look like the parent function at all. So what we want to do is change it so it looks like the rational function, parent function. And how do we do that? We have to do long division. 3x minus 7 divided by x minus 2. All right, so x goes into 3x how many times? 3. Okay, so 3x minus 6, and then subtract. What's the remainder? -1. And once we do long division, we're going to rewrite this in fraction form. How do we write this in fraction form? Huh? 3, sorry, say that again. 3? Uh-huh. Yes. Okay, now does it look like the parent function, 1 over x? Yes, it does. So this is the parent function kind of stuck right there. Now you have to figure out what the transformations are. I'm going to give you a hint. There are 3. All right, who can give me one transformation? Right 2, correct. What's another one? Yes, up 3. And the last one. Huh? Reflect what? Yes. How do you know it's x-axis and not y-axis? If it's y-axis, the negative would be here. But the negative is on the function, so it's outside. Okay. All right, so then let's graph this. We're going to do right 2, up 3. So the asymptotes are moving with it. And then reflect x-axis means that it's going to be in the 2, 4 quadrant instead of 1, 3. The exact places you don't know unless you actually plug in numbers. Okay, so pretty easy. This is probably still a review of Algebra 2. Now we're going to do things that you have not seen before. So recall from last section or last chapter, we did end behavior, where we used the limit notation. We're going to do the same thing now with vertical asymptote. Okay, so looking at the vertical asymptote, you have the graph coming from two ends of the asymptote. So the asymptote is in the middle, and then you have the graph coming from both sides. If it's coming from the right-hand side, we call that the positive side. Okay, if it's coming from the left-hand side, we call that the negative side. Okay, so where is this asymptote? Where is this vertical asymptote? At x equals what? 2. So then when we're coming to x equals to 2 from the positive side, okay, so when the graph is going to 2 from the positive side, where is y going to? Infinity, going up, right? So this is how we're going to write it. Limit as x goes to 2. Okay, when x is going to 2, but we have to tell them which side, because when you're talking about x equals to 2, there are two sides, and the graph looks very different. So we have to tell them exactly which side are you talking about, left-hand side or right-hand side. If you're going to talk about the right-hand side, you're going to say positive. So then what you do is you write a positive, but this is not 2 plus. This is plus in the superscript, like an exponent. Okay, so please write it as an exponent, not a 2 plus. Okay, 2 with a superscript plus. Okay, so when x is going to 2 from the positive side, f of x is going up. Y is going up, so y is going to infinity. And we're going to also talk about the left-hand side of the asymptote. So limit as x goes to 2, the left-hand side is going to be from the negative side. From the negative side, we put a minus in the superscript again. Not 2 minus, it's 2 with a minus on the top. Y, which is f of x, is going where? Negative infinity, yes, correct. Good? Kind of? Yeah. So let's try another one. This one here. All right, where is the vertical asymptote? 2. Yes. And then again, we're going to have a positive side of the asymptote and a negative side of the asymptote. So limit as x is going to 2. You got to specify the side because there are two sides of this asymptote. Let's say we're coming from the positive side. F of x, which is y, is going where? Everyone point to the direction you think it's going to. Down. So what do you write? Negative infinity, good. And then limit as x is going to 2 from the negative side, f of x is going where? Huh? Someone says infinity? Okay, let's have you guys try the last one. So limit as x is going to -3 from, from the positive side, f of x is going to infinity. And then limit as x is going to -3 from the negative side, f of x is going to -infinity. Good? All right, so this is new. So this is the limit that we are writing. So we want to be able to describe the behavior of the graph. So we're talking about the behavior as x approaches the vertical asymptote. And when we're talking about the vertical asymptote, we're talking about the positive side. Okay, positive side means from the right. And then the negative side, which is from the left. Okay, so whenever you have one vertical asymptote, you're going to write two limits. So eventually you're going to have more than one vertical asymptote. You're going to probably have three. Then you have to write 3 sets, which means 6 total limits. In addition to that, we still have end behavior. End behavior is when x is approaching the positive and negative infinity. So we still have end behavior. End behavior means when x is going to the two ends, where is y going to? So let's take a look at these again. Okay, so limit as x is going to infinity. Let's have you talk to your partner really quickly. Probably takes 10 seconds. When x is going to infinity, where is y going to? Talk to your partner. All right, let's vote. How many people say infinity? How many people say negative infinity? How many people say 0? Okay, 0 is correct. So when x is going to infinity, that is x going this way, the right-hand side, y is going to 0. Basically, y is always going to go to the horizontal asymptote. So if you just memorize that, it's always going to the horizontal asymptote. So same thing when limit as x goes to negative infinity, f of x is also going to 0. Okay, so the two ends are always going to go to the horizontal asymptote. All right, let's try this one. End behavior. End behavior means limit as x goes to infinity and negative infinity. So limit as x goes to infinity, where is y going to? And limit as x goes to negative infinity, where is y going to? Go ahead and try that. Okay, so when x is going to infinity and negative infinity, where is y going to? Very good. All right, we're going to not do the last one because it's kind of the same. All right, vertical asymptote, just another review. I know we did this last chapter already, but it's going to come back a lot. So let's review it again. So it's going to be a vertical asymptote only if the 0 of the denominator. So remember, if you have a 0 in the denominator, it usually causes a vertical asymptote. But only if it is not also the 0 of the numerator. Because what happens if it's a 0 in the numerator and the denominator at the same time? It's a what? No, so instead of a vertical asymptote, it becomes a whole. What's it 2? So whatever makes the denominator 0, if that number also makes the numerator 0, it cancels. It's going to be a whole. Do you guys still remember? Yeah? Okay. All right. So let's have you determine where the vertical asymptote is. Remember, when we're talking about the vertical asymptote, it's x equals to, not x not equal to. That's what you write for domain. But vertical asymptote is where is it? So you're going to tell me where it is. Okay, 1, 2, 3, 4. All right, let's see. Iris, number 1. X equals what? 1. Okay, Amelia, number 2. Yes. Josh, number 3. No, I is not actually a real number, right? It's imaginary, so it's not going to show up on the graph. So this one is no vertical asymptote. Okay, nothing makes the denominator 0. It's always positive. Trey, you have the last one. Oh, you got tricked there. Huh? -1 only, because 1 will actually cancel with the numerator, causing a hole, so that's not a vertical asymptote. All right, so just a quick review on vertical asymptote. Horizontal asymptote, another review. There are only 3 scenarios with when it's a polynomial situation. You have 3 situations when the degree of the numerator is smaller than the degree of the denominator. What is the horizontal asymptote? So for example, like number 2, the degree in the numerator is smaller than the degree of the denominator. So what is the horizontal asymptote? 0. Okay, so it's always going to be 0 if the numerator is smaller in degree than the denominator. Second case, when the degree in the numerator is equal to the degree of the denominator, what is the horizontal asymptote? The ratio of what? Of what coefficient? Yes, the leading coefficient. All right. Number 2, where is the horizontal asymptote? 2. Yeah, so the degrees are the same. We look at the ratio of the leading coefficient, which is just 2. Okay, last case, when the degree of the numerator is bigger than the degree of the denominator, then what happens? None. Yeah, no horizontal asymptote. But this year, we're going to talk about the slant asymptote. All right, we don't have time to actually do an example, so I'm going to tell you how to do it, and tomorrow we're going to actually do it. To find the slant asymptote, we use the long division method. And we're going to write it in fraction form. The quotient part is slant asymptote. So when the degree on the top is bigger, then we have to do long division. The quotient is the slant asymptote.